Hey, welcome back. Today we're going to be going over the next lesson in this SAT Desmos course, and our goal here is to kind of understand the use cases of inequalities and the overlap of shaded regions for specific problems. Now my goal is to kind of first teach you the concepts, and by the end you should be able to do this problem that I've shown you on the left side. And if you can, that means you've successfully understood the use case of inequalities on using Desmos right on the SAT. Also, this will be like the last beginner kind of lesson before we move on to more intermediate lessons next time. But let's get started, right? So SAT inequality questions often give several conditions and ask, which ordered pair makes all of them true? You enter the inequalities directly in Desmos, right? Each one kind of gives you like a shaded region, and the system solutions are the points where every shaded region overlaps, right? So we're gonna be diving into more of those types of questions, of course, later on. But let's start with the really, simple basics, right? So an inequality divides the coordinate plane into a boundary line, right? And then kind of like a shaded region, right? So a boundary line is kind of where the two sides of the inequality are equal to each other. So let's say I have this inequality, y is less than or equal to, and we're gonna say like negative 1/2 x, right, plus 4. So you can see obviously that there is this boundary line here, that red dark line, and then there's a shaded region that have kind of, as you can see, right, everything below that boundary line. So now, right, Desmos shades below the line in this case, right, and the boundary is solid because equality is allowed. Right? It's a less than or equal to sign. So that means any point that lies on this line itself is also a solution to this inequality, right? Or it fits this inequality. So, for example, the point 2 comma 3, right? That lies exactly on the boundary. So it actually is included in the inequality, right? Because this inequality allows for equality. The point 2 comma 1, you can see obviously it's uh, satisfies the inequality because it lies in that region, right? Whereas the point 2 comma 5 does not because, as you can see, it lies outside the region. So those are kind of the really basic things you should just know before we actually get to using inequalities, right? But when should you use inequalities? When the problem contains inequalities in both x and y, right? Um, when two or more inequalities must be satisfied, right? When that's the kind of multiple conditions part, right? Um, when you have several ordered pair choices that you have to test against multiple inequalities. I'm going to explain those use cases later. Uh, and of course, right, when you are given a word problem that describes like limits on two quantities, which is kind of like the one on the left side here. Now, when should you not use Desmos? It's when the question gives you a really like one simple inequality and just one point to check, right? For example, right, if you have uh, 3x plus y is less than or equal to 8, uh, and you're trying to see if the point 2 comma 1 satisfies it, right? I know it does using the graph here. We're trying not to use a graph in this case. Well, you don't need to use Desmos for this because you can just plug in 2 for x and 1 for y, right? You get 3 times 2 plus 1, which is 7. And of course, 7 is less than or equal to 8, right? So that's a really simple inequality where you don't really need to use Desmos. But let's get more into those use cases, right? So, uh, one of the use cases for using inequalities is a question might ask you which point satisfies an inequality. And I kind of already showed this to you. Um, but let's say you have 4x plus 3y is less than or equal to 18, right? And then so that's the inequality they give you, and you're trying to find which of these points satisfies 4x plus 3y is less than or equal to 18. Well, all you do is just plot these points, right? Okay, again, this is kind of something I showed to you earlier, right? So for example, like the point 0 comma 6 here, right? As you can see, it lies on the line, right? And inequality is allowed. So therefore 0 comma 6 is a valid point. 2 comma 4, on the other hand, is not. It's outside the region. Likewise, right? 3 comma 3, as you can see, is also outside the region. And 4 comma 1 is also outside the region, right? So that's kind of a way to use Desmos, right? You plot the points and see if it satisfies the inequality, right? Now, another use of inequalities, and actually an incredibly common one, is when you have to find the overlapping region. So you might have multiple inequalities in a problem. Let's say you have x is greater than equal to 0. You might have y is greater than equal to x plus 1. Um, and then let's say you have this last one here, right? Where you have negative 2x plus 7 is greater than 7, or greater than y, right? So you have these overlapping these regions, and you're trying to find which point satisfies the system. Well, the first thing you do is you find where this overlapping region lies, right? So where is the overlapping region here? Well, if you said something um, about this region here, right, highlighted by this triangle here, I'm going to try to highlight the points, right? You'd be right, right? That's where all these inequalities kind of lie. Now, the next step is to plug in or to plot the points. So for example, let's say you plug in 1 comma 1, right? You're given the point 2 comma 3. You're given the point 1 comma 3, and of course, you're given the point 3 comma 0. Right? So you're given these points. So how do you determine if which one of these is right? Well, you just got to look at which one lies in the region, right? In our case, it's that point there, 1 comma 3, right? Um, a common mistake is that you choose a point that lies in two shaded regions, but not the third one. So, for example, right, if you look at that red point, right, that lies in the green region and the black region, but it does not lie in the purple region, right? So that's kind of one way you can just say like, yeah, nope, that's not the right answer, right? Um, so once again, right, look for the point that lies in all those regions. In this case, it lies in the green region, it lies in the black region, and it lies in that purple region, right? I know sometimes it can be hard to tell what the overlapping region is because there's so many like different colors going on. What I like to do is tap each one first. So tap x equals greater than 0, and obviously you can see that the green point lies in that region. Then tap the purple one. You can see once again that the green point lies in that region. And finally, tap that black one, and again, it lies in that region. So that's kind of a way to check. So yeah, that's the most important part or most important use case for inequalities on Desmos. Now sometimes you might be given an inequality in context, right? It's pretty much the same. You just got to find which point lies, right, in that region. For example, let's say you're told that a school buys X notebooks for $2 each and Y folders for $3 each. It needs at least 24 items and can spend at most $60. Well, first of all, right, you know that the number of notebooks and the number of folders that the school buys has to be a positive number. So you can say right away that X is greater than 0 and that Y is greater than equal to 0. Now, I would actually, you could put these inequalities down, but I wouldn't because if you know that you're looking for positive numbers, um, just look for solutions that lie in the first quadrant here, right? You don't need to put those inequalities in because once again, they just create more colors and more distractions, right? But what else? Well, you know that the school needs at least 24 items. So that means the number of notebooks plus the number of folders has to be at least 24. So it has to be greater than equal to 24. and that's one inequality. Second, you know that each notebook costs $2 and that each folder costs $3. And that let's say that the school can spend at most $60. That means those two combined have to be less than 60, right? At most implies less than or equal to. So now you have these inequalities, and you're looking for, let's say, the point that kind of satisfies these inequalities, right? Well, one of them is actually going to be 12 comma 12, right? Because you'll notice that 12 comma 12 lies um on the boundary lines of both of these inequalities. And in this case, equality is allowed, right? So every time you have those that solid kind of line, and you might have different types of lines, right? For example, this could be a less than, but in this case, it's less than equal to. So anytime you have those solid lines, it implies that the point can lie on that line. So in this case, 12 comma 12 is a valid answer. 6 comma 18 on the other hand is not, because as you can see, it only lies on the blue kind of thing, right? It satisfies only the blue inequality, but not the green one. So that's kind of a case where you use Desmos to kind of identify the inequalities in a word problem, and then just plot them and figure out which points actually satisfy both of those inequalities. Okay, so those are kind of all these cases for inequalities. But now I'm going to be going over this question on the left side, right? So we're told that a theater sells adult tickets for $15 each and student tickets for $9 each. Okay, for one show, at most 24 tickets can be sold. Ticket revenue must be at least $310, and at least 8 student tickets must be sold. And essentially, they're trying to ask us to find the ordered pair that represents the ticket sales, right? An ordered pair that could satisfy these conditions. So first step is to first make those conditions, right? Write those inequalities. So we let's say that the number of adult tickets is X and the number of student tickets is Y. Well, we know at most 24 tickets can be sold. So that means the number of adult tickets plus the number of student tickets has to be less than equal to 24, right? Uh, what else do we know? We know that the total revenue must be at least $310. Well, each adult ticket costs $15, right? So 15x gives us the total amount of revenue generated from adult tickets. And then 9y, which is, by the way, 9 is the cost for each student ticket. 9y gives the total revenue generated from the student tickets. And you know that combined, the total revenue must be at least 310. So it has to be greater than or equal to 310, right? And finally, you know that at least 8 student tickets must be sold. That means y has to be at least greater than or equal to 8. So you have those three regions. Now, which of these points satisfy those regions? Well, first of all, what I would do is plot all these points. So you have 16 comma 8, 15 comma 9, 17 comma 8, and finally 18 comma 6, right? So which of these points kind of lies in all those regions? The red, okay, yeah, the red, the blue, and the green. Which one of them lies in all? You can see that these points are kind of clustered here, so I will zoom in a bit. So, well, in our case, right, if you look at the red region, you can see that obviously the red point does not lie in that region, right? That 17 comma 8 does not lie in the region of the red. So that's not a solution, right? What else? If you look at the blue region, you will see that the black point does not satisfy, right? It lies outside the blue region, so you can cross that out. Um, Finally, uh, if you look at the green region, you will see that the blue point here, 18 comma 6, does not lie in that green region, so you can cross that one out. So therefore, you're left with only one answer choice, which is 16 comma 8, and it lies on the boundary of the red line. it's in the blue region and it also lies on the boundary of the green. So therefore, 16 comma 8 is our answer choice here, and you would select A as your answer. So I hope that kind of made sense. Inequalities can be really hard to do manually because you really don't want to be testing each single point. So knowing and mastering how to use these inequalities on Desmos, finding the overlapping region, and then selecting the point that satisfies that overlapping area genuinely is incredibly helpful for inequality questions. Right. So I hope you found this video to be helpful. If you have any questions, please leave it down in the comments. And stay tuned for our first intermediate level lesson in this course. Thank you.